In this video, we're going to go over the tangent-secant angle theorem. Now let's look at the statement. If line AB is tangent to the circle C of O, OB at point B, and if AD is a secant line to the circle, then the measure of the angle BAD is half the positive difference of the two intercepted arcs. In the figure below, we have a typical configuration of this theorem, and, we claim that the measure of the angle BAD is 1/2 of the absolute value of the difference between the measures of those two arcs, BPC and BQD. Specifically, in our figure, in our configuration here, the arc BPC is a minor arc, and the arc BQD is a major arc. So this absolute value is going to be equivalent to the measure of BQD subtract the measure of BPC. Compared to the two tangent angle theorem, you can easily see that these two theorems are sort of the supplemental to each other. Now, without further ado, let's look at the proof of this theorem. What we're going to do is observing that if we draw the chord joining the points B and D, then we could apply the tangent chord theorem to conclude that the angle, well, for the sake of convenience, let's put a point here and call this point E. So the angle EBD is going to be equal to 1/2 the measure of the arc BQD. So let's write this down before we move forward. So we observe that by the tangent chord angle theorem, the angle, the measure of the angle EBD, it's the same as 1/2 the measure of the arc BQD. And this is going to be useful in the sense that we observe that the angle EBD is in fact an exterior angle of the triangle BAD, as we have seen up there. Hence, we could make use of the following fact as an exterior angle of the triangle ABD. We have the measure of EBD equal to the sum of those two non-adjacent angles, non-adjacent interior angles of the triangle ABD. Namely, it's going to be equal to the sum of the measure of the angle BAD and the measure of the angle BDA. Now note that the angle BDA is in fact an inscribed angle of this circle. So we observe that as an inscribed angle, the measure of BDA is equal to 1/2 the measure of the arcs that is being intercepted. Namely, it's going to be 1/2 the measure of the arc BPC. Now, putting things together, we have the following conclusion, that the angle, the measure of the angle BAD, which is the measure of the angle that we're going to find, it's equals to the difference between the measure of the angle EBD and the measure of the angle BDA. But each of them could be replaced by 1/2 of the measure of some arcs, as we have observed in the previous argument. Respectively, the measure of the angle EBD is going to be equal to 1/2 the measure of the major arc BQD, and the measure of the angle BDA is equal to 1/2 the measure of the minor arc BPC. And this is precisely the conclusion that we would love to draw. And this is the proof.